Hello, students. We are here to discuss arithmetic reasoning today. So, if you are new to our channel, please subscribe to our channel on YouTube. Also, follow us on Instagram and Telegram. You can get the link of all that is Instagram as well as Telegram channels in the description box. Along with this, you can download free study material for design and architecture entrance exams, and link for the same will also be available in description box. So let us start our session. So today the topic of discussion is arithmetic reasoning. What is arithmetic reasoning? How is it, why is it called arithmetic reasoning? How is it different from arithmetic aptitude? So when we talk about arithmetic reasoning, it is a part of reasoning that requires intensive use of arithmetics or basic concepts of arithmetics, right? It is different than arithmetic aptitude because in arithmetic aptitude, we have a particular question and we have a particular possible solution. Here, we have to think of different possibilities when it comes to reasoning, right? That is why reasoning is different than arithmetic reasoning is different than arithmetic aptitude part or quantitative aptitude part, right? So let us understand it well with the help of examples. So the very first example is on our screen now. It says a girl counted in the following way on the fingers of her left hand. She started calling thumb 1, the index finger 2, the middle finger 3, the ring finger 4, little finger 5, and then reverse the direction by calling ring finger 6, middle finger 7, index finger 8, and thumb 9, and so on. So she counted up to 1994. Now, the question is, she ended counting on which finger? So I hope we are able to identify the pattern. So the pattern here is one, when she counted one, it was her thumb. When she counted two, it was her index finger. When she counted three, it was her ring finger. When she counted four, it was, sorry, pardon me. Uh, it should be when she counted one, it was thumb. When she counted two, it was her index finger. So for two, it was her index finger. For three, it was her middle finger. For four, she counted four on her ring finger, five on her little finger. And then changing the direction, that is six on ring finger, seven middle finger, eight index finger, and nine once again on thumb. And then the pattern gets repeated. So we can say the pattern here is 8n plus 1. That is, if I put n equals to 0, at 1 I'll have thumb. If I put n equals to 1, this whole part becomes 9. And at 9 also I'll have thumb. N equals to 2, the value I'll get is 8 to the 16 plus 1, 17. So at 17 also I'll have thumb, right? So now try to have this 1994 with this 8n plus 1 part, right? So 8n plus 1 is equals to 1994. Right now, I don't know whether it will be exactly correct or not, but let us try to reach as close to this one so that after that, for remaining part, we can count which finger should be the right answer. So that gives 8n equals to 1993. And definitely this 1993 is not divisible by 8 because it is an odd number. So we'll try to have a number that is completely divisible by 8. So let us try to have that number. And 1993, if we divide this 1993 by 8, if we divide this 1993 by 8, we will have 1993 divided by 8, 8 twos are 16, remainder is 3, 3 9 39, 8 fours are 32, difference is 7, 7 3 73, 8 nines are 72, and the remainder is 1. So for 249, for the value of n equals to 249, the value will be 1993, and we'll have thumb here again. So let's try to calculate 249 into 8. 8 nines are 72, 8 fours are 32 plus 7, 39, 8 twos are 16 plus 3, 19, plus 1, that is 18 plus 1 gives us 1993. So we need to add one more because this remainder is 1 here. So remainder, thumb, then index. So the correct answer will be index finger, right? Excuse me. So here, how is it different than arithmetic questions? So in arithmetic questions, we don't have to think of these logics and all, right? We just have certain standard situations and we put certain formula for that situation and we are able to achieve the answer. But here, we need to exercise the reasoning aspect as well as the arithmetic concepts. That's why this is called arithmetic reasoning, and that's why it is different than the regular quantitative aptitude part or regular reasoning. Let's move to next question. Aaron cut a cake into two halves, cuts one half into smaller pieces of equal size. Each of small pieces is 20 grams in weight. If he has 7 pieces of the cake in all with him, how heavy the original cake was, or how heavy was the original cake? So see here, say this was the original cake. So first of all, he cuts it into two equal halves. This is half one and this is half two, right? Pardon me for my drawing skills, right? And then he divides this second half, one half, into smaller pieces such that he have 7 pieces in all. So one piece that has not been divided further, and 6 pieces. One, two, three, four, five. One, two, three, four, 5 and 6. So this is 1, this is 2, this is 3, this is 4, this is 5, and this is 6. Right? 6 pieces equal weight, and each has a weight of 20 grams. So 20 into 6 is 120 grams. And this H1 is equal to H2 because it says cuts into two halves. If there are two halves, they both are equal. So its weight should also be 120. So 120 plus 120, total weight should be 240 grams, right? Let's move to next question. What we did here, quickly let's recall it. As per the question, Aaron cuts a cake into two halves. So he divided into two halves, and then one of the halves has been further divided into smaller pieces of equal weights. And overall, Arun has 7 pieces of cakes. So one piece that was the larger one that has not been divided, and the remaining 6 pieces were of the second half that has been divided into 6 equal pieces. That has to be divided, that was divided in equal pieces, and those 6 pieces, each piece has a weight of 20 grams. So total weight of the half that has been divided into 6 pieces is 120 grams, and similarly, the half that has not been divided has also a weight of 120 grams. So overall weight of the cake has to be 120 plus 120, that is 240 grams. All right, let's move to next question. When Rahul was born, his father was 32 years older than his brother. His mother was 25 years older than his sister. So at the birth of Rahul. Rahul's father was 32 years older than Rahul's brother, and Rahul's mother was 25 years older than Rahul's sister. If Rahul's brother is 6 years older than him, so Rahul's brother is 6 years older than Rahul, and his mother is 3 years younger than his father. So Rahul's mother is 3 years younger than Rahul's father. How old was Rahul's sister when Rahul was born? When he was born, so he represents Rahul, right? So from these equations, we need to determine. There are two ways to do it. There are two ways to do it. Either you can go by options or you can establish relations here and then go ahead. So Rahul's father is 32 years older than Rahul's brother. Rahul's mother is 25 years older than Rahul's sister, right? And finally, we need to determine Rahul's sister's age when Rahul was born. Okay? At the birth of Rahul, what is Rahul's sister's age was. So we need to convert these all things into Rahul's sister. So Rahul's mother and father can be established relation. We can establish a relationship between Rahul's father and Rahul's mother. So Rahul's father can be replaced as Rahul's mother plus 3, right? And Rahul's mother can be replaced as 25 plus Rahul's sister. So Rahul's mother is 25 plus Rahul's sister, and Rahul's father is 3 years elder than Rahul's mother. So that is Rahul's father for us. So Rahul's father is 28 years older than Rahul's sister, right? So Rahul's father, 28 years older than Rahul's sister. Rahul's mother, 25 years older than Rahul's sister. Now who is remaining? Rahul's brother. So Rahul's brother is Rahul's father minus 32 years. Transfer this 32 on the other side. And we have a relationship that is Rahul's father is 28 years elder than Rahul's sister. So Rahul's brother, if I replace Rahul's father here, so that will be Rahul's brother plus 32. So Rahul's brother plus 32 is equals to 28 plus Rahul's sister. So Rahul's brother is equal to Rahul's sister minus 4, right? And now we have relationship that is Rahul's brother is 6 years older than Rahul. So at the birth of Rahul, his brother was 6. So if Rahul's brother was 6, Rahul's sister has to be 10 years older, right? So from here, we can determine this value as well. Let's move to next question. In enterprising, businessman earns an income of rupees 1 on the first day of his business. On every subsequent day, he earns an income which is just double that of that he made on the previous day, right? On the 10th day of the business, his income was. So on first day, his income was rupee 1. On second day, his income has to be double, that is rupee 2. On third day, his income has to be rupee 4. So we can form a pattern here, that is 2 to the power 0, 2 to the power 1, 2 to the power 2, or I can say 2 to the power n minus 1. So on 10th day, it will be 2 to the power 10 minus 1, that is 2 to the power 9, that is 512. So correct answer to this one should be 512. Let's move to an interesting question. It is two old friends, Jack and Bill, meet after a long time, right? So as two friends meeting after a long time having a conversation, Jack said, Jack says, "Hey, how are you, man?" Bill responds, "Not bad. Got married. I have three kids now." Jack, "That's awesome. How old are they?" So Bill did not respond that him directly, but gave him a mathematical puzzle or a reasoning kind of situation. So he has to reason it out. The product of their ages is 72, and the sum of their ages is same as your birth date, right? So here is the point where we should enter. So there are three children, child one, child two, child three, and if we multiply C1, C2, and C3, we'll get 72, and we'll get some value by adding them. What that value would be, sir? We don't know. How can we determine the birth date of the man called Bill? No problems. Let's try to have factors of 72. So 72 has to be factorized here, and it has to be factorized in a manner that it has three factors, right? So 72, if we write it, it is 8 into 9. If you further break it, it is 2 to the power 3 into 3 to the power 2 into 1. So here we can have certain different combinations, say 2. If it is 2, the other could be 2 to the power 2, that is 4. The third one could be 9, right? So product of these three is 72, and sum of these three is 4 plus 9, 13 plus 2, 15. 2 plus 4, 6, 6 plus 9. So can we write it 8, 9, and 1? Yes, we can write it 8, 9, 1 as well. So it is 72. 8, 9 plus 9, it is 18. Excuse me. Then can we write 6, 6, 1? No, we cannot write 6, 6, 1, but 6 into 6, 36 into 2 will be 72. We can write this one. So this is 6 into 6, 36 into 2, 72, and sum is 14. Let's go with few more possibilities. That is 2 to the power 3 into 2, 8 into 3, 24, right? Into 3 into 1. This is also 72. 24 plus 3, 7 plus 1, 28. Also, what can we write it as? It is 2 into 2 into 2 into 3 into 3 into 1, right? So let's try to break it as we have 2, 8, 4, 2, 4. So if I keep 4 here, if I keep 4 here, if I keep 12 here, right? So 4 into 12 is 48. 48 into something will not give me 72 because the age has to be an integer. So that is not happening. But yes, I can have 6, 12, and 1. 72, and it will be 19. What else? 18 fours are 72 plus 1. 18 4 1. 18 fours are 72. 8 plus 18 plus 4, 22 plus 1, 23. Further, further, what else? What else can we do? See, 9 into 4 into 2. 9 into 4 into 2 we have done. 942, 249 is the same thing. So 3 into 3 into 8, right? This is remaining. We can have twins with age 3, 3 and 8 as well. So 8, 3, 3. This is 8, 3, 11, 3, 14, 72, and sum is 14. So these are certain possibilities. But here, if the person knew his date of birth, he still asks, cool, but I still don't know why he asks. Because there are two possibilities that are giving you sum 14. So the answer has to be one of these two. That is either his Jack's either Bill's children are 6, 6 and 2 or 8, 3 and 3. That is why Bill, who knew his birth date is 14, asked, but I still don't know. Bill says, my eldest kid just started taking piano session. So eldest is only one. Eldest kid, eldest kid. So here we have two of same age. Here we have only one who is eldest. So the answer to our situation should be this one. How old are Bill's kids? So it has to be 3, 3, and 8. Correct answer here. I hope now you can differentiate why arithmetic reasoning is different than quantitative aptitude, why it is not a regular conventional arrangement kind of reasoning. Let's see a next set of questions this will also give you a few insights. So it says this is alphanumeric kind of situation. We have certain alphabets, and each alphabet is replaced by a letter. It says, given below is a representation of mathematical addition of two numbers, where numbers have been replaced with specific alphabets. Each alphabet stands for a specific single digit number, right? Say D. So D can have any value from 0 to 9 because single digit number, right? So single digit numbers are from 0 to 9. That is overall 10 numbers we have, right? So let's see how we are going to take it, how things are given to us, and how can we approach it. It says none of the numbers is represented by more than one alphabet. So each alphabet has a unique digit or unique number between 0 to 9. If D is say 0, then none other alphabet can have value 0, right? So what do we need to determine now? Cent plus more gives us money. That is, two 4-digit numbers are added and the result is a 5-digit number, right? So let's first of all try to note down different alphabets that have been used here. So the very first is D, and then the second one is E. After E, F, G is not here. H is also not here. H, I, J, K, L, M. M is here. N is also here. O is also here. M, N, O, P is not here. Q is not here. R is here. S is also here. S, T, U, V, W, X, not here, but Y is here. So how many different alphabets do we have? 1, 2, 3, 4, 5, 6, 7, and 8. So each alphabet will have a unique digit assigned to it, and we will try to decode that value, right? So from here, I can see that this S plus M gives us O and one carry, that is M. So whenever we add two numbers, we always get a carry as 1, right? So we always get a carry as 1. So from this insight, I can say this M has to be 1. So what if there was a carry from here? Okay, if there was a carry from here, that also can be 1 only. Can that carry be 2? Sir, can that carry be 2? Possibly. Let's see if that carry was 2, then this should be 9 plus 9, 18 plus 2, 20. So M can have value as 2 as well. But that cannot be possible. Why? Because it says each alphabet stands for a specific single digit, and we have two different alphabets. And we have two different alphabets. And the value of m, as per our discussion, could be 1 or 2, not 9, not 9, right? So it has to be 1 only if it is m. It cannot be 2, right? So maximum possible carry for when two numbers are added is 1. So value of m is 1. So let me write it 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Out of these many digits, we already have consumed 1, right? So if m is 1, this O has to be 0. Can I say so? If this is 1, this is 9, then this is 10, and this O is equal to 0. If not, this S is 8, then we have a carry of 1. 1 plus 8, 9, 9 plus 1, 10, right? If this is 9 and this is 1 and we had a carry of 1, then it would be 11. So this should be M, not O. So from here we can determine this O is all O value of O is 0. Value of O is 0. So we are able to decode these two values. This is 1, this is 0, right? So from here I can say this E plus N is equals to E plus 1. N is equals to E plus 1 because it is not E plus 0 should be either E or there was a carry of 1, then only it is E. It is not E but N, right? So N is equals to E plus 1 I can identify, right? Then what happens here? What happens here? Meanwhile, let me get you back. If this n is e plus 1, so I can surely say there is no carry. The carry over from this side is 0, and then the value of s has to be 9, nothing less than 9, because if it is at 8 plus 1, 9, and there won't be an additional digit, right? Instead of 5, it would have been 4-digit number. So for the value of s is 9 for sure. Right. So now let's try to decode this part. Let's come back to this part. D plus E gives us Y and there has to be one carry. Why there has to be one carry? Because if there is no carry, 1 N plus 1, this N is nothing but E plus 1. E plus 1 plus R can give us 10 plus E, right? And that is 1 plus E is equals to N. So either there is a carry if this is D plus E. So I am writing two possibilities. As reasoning always deals with possibilities, or D plus E is equals to simply Y, no carry, right? If there is a carry, then I'll write N plus 1, that is E plus 1 plus 1 plus R is equals to 10 plus E. And here it is 10 plus E that I am sure about. Because if there is a carry of 1, then only it is 1 plus E giving me N. All right. So from this, I can say R plus 2 is equals to 10. E gets cancelled from the both sides. R plus 2 is equals to 10. So R is equals to 8. And if there is no carry, this R would be equal to 9. If this is E plus 1 plus R is equal to 10, that means 10 plus E, that means R is equal to 9, and this is not possible as we already have S is equals to 9. So D plus E is not equal to Y, but D plus E is equals to 10 plus Y. So this possibility eliminates, and I can surely say there exists only one possibility, and that possibility is D plus equals to 10 plus Y, and hence R is equals to 8. So R is equals to 8 is also done. Now, this D plus E is 10 plus Y. So this Y can be 2, 3, 4, right? Something like that. Or say 5, 6. 7. So these are the possibilities remaining for the value of y. So let's try to have these two added, and we have e plus 1 equals to n. So I can definitely say e cannot be e cannot be 7. E cannot be 7. If I say for value of e cannot be 7. Why? E cannot be 7 because e plus 1 is n, and we already have assigned 8 to a digit, right? So e could be, at max, e could be 6, right? If this is 6, this has to be 6, then only it is 12. If this is 6, the d has to be 7, 6 plus 7, 13. So 3 carryover is 1, right? These are the two possibilities. So if E is 6, D has to be 7. If E is 6, D has to be 7, and which this case cannot happen because E plus 1 is N. So N and D will have same values. So this is not happening as well. So I can surely say E is not equal to 7 or 6. E cannot be equals to, E cannot have value 6. E cannot have value 7. So the E can have value 5, 4, 3, 2. If E is 2, then D has to be 8. So this is also not happening. E is not equals to 2. If E is equals to 3, D has to be, if E is equals to 3, D has to be 7. Then 7 plus 3, 10. And this cannot be 10 because Y is 0. And Y, the minimum value of Y should be 2, right? So E cannot be equals to 3 as well. If E is 4, D is 7, 4 plus 7, 11, right? 4 plus 7, 11. Carry over Y, value of Y is 1. That is also not possible. So E cannot be 4 as well. So the only possibility for E is 5. So if E is 5, if E is 5, it is known to us, then the value of D could be. What could be the value of D? If E is 5, if E is 5, I can definitely say N is equal to 6 from this part, right? So D has to be 7. D has to be 7. D does not have any other choice because it is generating a carry. So D is equal to 7. So D is equal to 7. So 7 plus 5, 12. So Y is equals to 2. Y is equals to 2. So which digits we have not consumed is 3 and 4. So this is what our next question is. Which of the digits are not represented by any letter? The digits are 3 and 4. Let's look at the next question. What is the value of n into r? N is 6, r is 8. 6 into 8, 48 is the right answer. The value of r is 8. The value of r is 8. Let's see the next one. What is the value of MEND? M is 1. See here. M is 1. E is 5. N is 6. So 1, 5, 6, 7. MEND. 1, 5, 6, 7. It is option B here. The next question is value of SORRY. So S was 9. O is 0. R was 8. R was 8. And Y was 2. So 90882. That's to be option A. So this is how we solve this kind of arithmetic reasoning questions, right? Some represented by letters, then we need to decode the values of these letters. Instead of this sum, there could be a multiplication as well. There could be a division or subtraction as well, but there are majorly chances of multiplication or addition. So try to explore this side as well. Let's move to next, write down the letters. The very first letter I have is A, then I have C, then I have D, then E, F, F is there, G, H, G is there, 1, 2, 3, 4, 5, 6, 7. So there has to be some error because here G is not there and here G is happening. right? J is 3 more than F. J is 3 more than F, not 1 more than. J is 3 more than F. So F plus 3 is J, right? That is G, not H, and not C. This is G, not C. This has to be G. So A, D, F, G, H, J, and S. These are the letters here. It says F is as much more than S. The very first clue is F minus S is equals to G minus F, or I can say F is equals to G plus S by 2. Second, A is less than D. So A has to be smaller than D. Third, A is 4 less than D. So A, 1, 2, 3, and D. 1 less, 2 less, 3 less, 4 less. So I can say D minus A is equal to 4. Fourth, H is 1 less than highest. So highest is equals to 7. So H is equal to 6. And the fifth one is J is 3 more than F. So J is equals to F plus 3. Right. So the minimum value for J has to be, the minimum value for J has to be, if F is at 1, J is at 4. So minimum value of J is 4. So J can have 4, 5, 7. H is already at 6, right? The minimum value for G for G has to be 5. So the minimum value for G has to be 5. So G can have any of the two values, that is 5 or 7, but not 6, as H is 6, right? Then let's try to arrange using this situation. So 1, 2, 3, 4, 5, 6, 7. So if I put G at 7, if I put G at 7, H at 6, F has to be on 4, that is 1, 2, 3. Then F plus 3, 1, 2, 3, not happening. So F cannot be on 4 if G is at 7, because J is 3 more than F, right? So for F, for that, if F is at here 1, 2, and 3, so J is here, F is at 2, and G minus F cannot be equals to F minus S. So S can be here only. Then this F minus S is 1 and G minus F is not 1. So G cannot be at 7. So for sure G cannot be at 7. Then G has to be on 5. So then G has to be on 5. So if G is on 5, can I say F on 4? So if F on 4, then S is on 3. So G minus F is 1. F minus S is also 1. So this condition is satisfying. J is F plus 3, 1, 2, 1, 2, and 3. So J is at 7. So this condition is satisfied. A is 4 less than G. So 1, 2, 3, 4. A is, this condition is also satisfied. This condition is also satisfied because D is here. So this is how our final structure should look like. So value of A will be 1, value of D will be 2, value of F will be 4, value of S will be 3, value of J will be 7, right? So this is how it is happening. So value of F is 4. Let's see the next one. S plus G. S is 3, G is 5. So 3 plus 5, 8 it is. The last one is D cross J. So that is D is 2, J is 7. So 7 into 2, 14 would be the. So let's have last two questions for today's session. That is arithmetic reasoning. A boy asks his father what is the age of grandfather. Father replied, he was X years old in which in the year which is numerical, which can numerically be expressed as x square. This is x square, which is that which is in the 20th century. So 20th century, it means from 1901 to 2000. This is 20th century. So there is a number that is a perfect square of, so 1901 to 2000. There is only one perfect square, and that one perfect square is 1936, and this is a perfect square of 44. So how can we determine that? How can we judge that? See here, 1900 and 2000. So we already know that 40 square is 1600 and 50 square is 2500. So in between the middle number 45, we can always determine the square of any number that is ending with 5 easily. That is 5 square is 25 and 4 next number 5. The next number 4 plus 1. Whatever the number is here, add it by 1 and then multiply it with this number. That is 5 into 4, 20. So it is definitely it has to be somewhere less than this. So I will check with 44. So 44 square is 44 square is, you can calculate 44 into 44 using the conventional way, or you can also use Vedic mathematics way. So I'm going with the Vedic mathematics way. That is 4 into 4, 16. Carry over is 1. 4 into 4, 16. 4 into 4, 16. 16 plus 1, 17. 4 into 4, 16. 4 into 4, 16. 16 plus 16, 32 plus 1, 33. Carry over is 3. 4 into 4, 16 plus 3, 19. So that gives me 1936, right? So that X is 1936 and he was X years old. So the grandfather was 44 years old. So grandfather was 44 years old. The value of X is 44. This we have decoded. Let's see the next question. What is the birth year of grandfather? So in 1936, the grandfather was of the age 44. So birth year has to be subtracted. So 6 minus 4 is 2. 3 minus that is 13 minus 4 is 9. 9 minus 1 is 8. So it has to be 1892. Right, guys? So thank you, guys. Thank you for connecting with us. Do subscribe to our YouTube channel. Follow us on Instagram and Telegram for more content, regular updates on all design and architecture entrance exams and preparation for the same. Thank you. Have a good day.